Background and history. Introduction. AI plays a crucial role in wildlife conservation efforts, offering innovative solutions for monitoring and protecting endangered species and their habitats. Historical context. Wildlife conservation practices have evolved alongside technological advancements, with AI emerging as a powerful tool in the conservationists' arsenal. Early applications. Early applications of AI in wildlife conservation focused on developing systems for species monitoring, habitat mapping, and poaching detection. Importance of AI. AI-driven approaches are essential for addressing the complex challenges faced by wildlife conservationists, including habitat loss, poaching, and climate change. Key figures and institutions. Notable figures and institutions pioneering AI in wildlife conservation include Dr. Serge Witch from Liverpool John Moores University and the World Wildlife Fund, WWF, among others. Historical impact. Examination of impact. AI has significantly impacted wildlife conservation practices by providing efficient tools for species monitoring, anti-poaching efforts, and conservation planning. Landmark studies. Landmark studies and projects using AI for species monitoring and protection have demonstrated the effectiveness of AI-driven approaches in safeguarding biodiversity. Societal and environmental implications. AI-driven advancements in wildlife conservation have profound societal and environmental implications, including improved biodiversity conservation, habitat restoration, and ecosystem resilience. Evolution reflections. The evolution of wildlife conservation practices has been influenced by AI technologies, leading to more data-driven, adaptive, and proactive conservation strategies. Influence of historical events. Historical events and policy decisions, such as increased awareness of biodiversity loss and the establishment of protected areas, have catalyzed the development and adoption of AI in wildlife conservation. Historical milestones. Key milestones. Significant milestones in the history of AI applications in wildlife conservation, including the development of AI-powered tools for species identification, population monitoring, and habitat assessment. Influential algorithms and technologies. Introduction of influential AI algorithms and technologies for species monitoring and protection, such as computer vision for image recognition, machine learning for predictive modeling, and drones for aerial surveillance. Landmark achievements. Landmark achievements in using AI for tracking and studying endangered species, including the development of acoustic monitoring systems, satellite tracking devices, and DNA analysis tools. Combating illegal wildlife trade. Development of AI-powered tools and techniques for combating illegal wildlife trade, including algorithms for identifying poaching hotspots, analyzing trade patterns, and disrupting trafficking networks. Collaborations and partnerships. Recognition of collaborations and partnerships driving advancements in AI and wildlife conservation, involving researchers, conservation organizations, government agencies, and technology companies. Technological advancements. Machine learning advancements. Advancements in machine learning and computer vision have revolutionized wildlife monitoring, enabling automated species identification, behavior analysis, and population estimation. Advanced tracking systems. Impact of AI on creating advanced tracking and identification systems for endangered species, allowing conservationists to monitor individual animals, study migration patterns, and assess habitat use with greater accuracy. Aerial surveillance with drones. Development of AI-powered drones and sensors for aerial surveillance of wildlife habitats, providing real-time data on ecosystem health, habitat fragmentation, and illegal activities such as poaching and deforestation. Data analysis and predictive modeling. Integration of AI in data analysis and predictive modeling for conservation planning, enabling conservationists to identify priority areas for protection, assess conservation interventions' effectiveness, and forecast future conservation challenges. Enhancing conservation efforts. Opportunities for using AI to enhance the efficiency and effectiveness of wildlife conservation efforts, including optimizing patrol routes, identifying emerging threats, and engaging local communities in conservation decision-making. Challenges and risks. Technical development challenges. Technical challenges in developing AI algorithms for species identification and tracking, including data scarcity, model generalization, and algorithm robustness in challenging environmental conditions. Ethical considerations. Ethical considerations in using AI-driven surveillance and monitoring systems in wildlife habitats, such as privacy infringement, data security, and the potential for unintended consequences on non-target species. Algorithmic bias risks. Risks of algorithmic bias and errors impacting conservation decision-making, leading to misinterpretation of data, flawed prioritization of conservation actions, and unintended harm to wildlife populations or ecosystems. Disruption of natural ecosystems. Concerns about the potential for AI to disrupt natural ecosystems or harm wildlife populations, including unintended consequences of AI interventions, ecological imbalances, and unintended wildlife habituation or displacement. Social and economic impacts. Perspectives on the social and economic impacts of AI-driven wildlife conservation interventions, including considerations of equity, justice, and community involvement in conservation decision-making processes. Future prospects. Speculation on the future. Speculation on the future of AI in wildlife conservation and species protection, envisioning more sophisticated AI technologies for biodiversity monitoring, conservation planning, and community engagement. Emerging technologies. Exploration of emerging technologies and methodologies for AI-driven conservation initiatives, including advancements in remote sensing, sensor networks, citizen science, and participatory monitoring approaches. Addressing new challenges. Opportunities for using AI to address new and emerging challenges in wildlife conservation, such as climate change adaptation, invasive species management, disease monitoring, and habitat restoration. Scaling up conservation efforts. Challenges and opportunities in scaling up AI-powered conservation efforts globally, including capacity building, technology transfer, policy alignment, and financing mechanisms for sustainable conservation initiatives. Interdisciplinary collaboration. Importance of interdisciplinary collaboration in realizing the full potential of AI in wildlife conservation, fostering partnerships between conservation biology, computer science, engineering, social sciences, and policy-making communities. Controversies and debates. Ethical implications. Debates surrounding the ethical implications of using AI in wildlife conservation practices, including concerns about data privacy, informed consent, indigenous rights, and the equitable distribution of conservation benefits. Protected area surveillance. Controversies over the use of AI-driven surveillance systems in protected areas, raising questions about privacy violations, human rights abuses, and the militarization of conservation efforts in sensitive ecosystems. Balancing innovation and ethics. Perspectives on the balance between innovation and ethical considerations in AI-driven wildlife conservation, emphasizing the need for transparent, participatory, and culturally sensitive approaches to conservation decision-making. Impact on traditional approaches. Discussions on the impact of AI on traditional conservation approaches and local communities, exploring opportunities for technology transfer, capacity building, and community empowerment in conservation initiatives. Calls for transparency. Calls for transparent and participatory approaches to AI-driven wildlife conservation research and implementation, advocating for open data sharing, community engagement, and accountability mechanisms in conservation projects. Additional information. Resources for further reading. Resources for further reading on AI in wildlife conservation, including academic journals, conference proceedings, books, and online platforms dedicated to conservation technology. Organizations and initiatives. Information on organizations and initiatives leveraging AI technology for species protection, including non-profit organizations, research institutions, government agencies, and technology companies involved in wildlife conservation. Educational materials. Educational materials for individuals interested in learning more about AI-driven conservation technologies, including online courses, webinars, workshops, and training programs on wildlife monitoring, conservation planning, and community engagement.